Right, so is bajillion a word?
No.
Sure it is. Okay.
How many zeros?
They used it on a commercial. I heard it one time.
How many zeros does it have? One.
It's got a bajillion zeros behind it. So, what is 400 bajillion times 0?
Zero.
It is 0. Very good. I'm proud of you. That's it for the day. Let's go home. So when kids learn about 0 and they learn about multiplication with 0, it's sometime in elementary school, and every kid goes home and tells their parents, hey, guess what 4 bajillion times 0 is? So they make up some ridiculously large number, multiply it by 0, and they're really proud of themselves because they can get the answer, even with that gigantic number in there. Okay? And that's a little silly, but it illustrates a good point. That 0 property of multiplication is really quite powerful. It takes whatever that number is and turns it into a 0. Okay? And there's a huge amount of information in a multiplication problem whose answer is 0. So if we take a look at this next example right here, it says if y times 0 or y times x equals 0, can you say anything about x and or y? Yeah. At least one of them's got to be 0. Because in order to make a 0 in a multiplication problem, you've got to have a factor of 0 somewhere in there. Either the first one or the second one has to be 0, or they could both be 0, which could happen occasionally, but one of them's got to be 0. Now, can we say anything about this problem right here? If we have x plus y equals 0, John, what can we say there?
At least one has to be negative.
At least one of them has to be negative. Okay? We could say more specifically that they've got to be opposite signs but the same number. If one's a positive 8, the other one's got to be a negative 8. Okay? But we can't know for certain what number they are. Does that make sense? So in this problem, we know something about the numbers, but we don't know anything about what number one of them has to be. If we've got a multiplication problem, we know for absolute fact one of them has to be 0. Okay? And that's the power of the 0 property of multiplication. Okay? So we've been factoring polynomials for quite a while, and this is what I would call the first good application of this, and it's for solving equations that look like this. So if we looked at this equation and said, you know, I just have to come up with a number when I square it and then add it to 4 times that number and then add 3, I get 0. Finding the answer to an addition problem that has an answer of 0, okay, solving an equation, it's got an addition problem that equals 0, is a lot more difficult than solving an equation like this that's a multiplication problem that equals 0, okay? So right now, we're kind of like on this line right here. We've got it set equal to 0, but it's an addition problem. We don't know very much about those numbers. If I could turn that into a multiplication problem, I'd be in much better shape. And that's where factoring comes in. Okay? So if I write this as a multiplication problem, which we can easily do, because that's an easy type of trinomial, I need two numbers that multiply to be 3 that add up to be 4. So I'm going to add positive 3 and positive 1. So they multiply to be 3, they combine to be 4. This is the right factoring. Correct? Okay, now how does that help us? Yeah.
Well, now we know one of the things in parentheses has to be.
We know that at least one of these factors in parentheses has to be equal to 0. So we've gone from a complicated addition problem to a less complicated multiplication problem where we actually know something about the numbers. And we can say that either x plus 3 has to equal 0 or x plus 1 has to equal 0. So if I solve this one, I do that by subtracting, so I get x equals negative 3. There's one answer. And if I do this one, again solving by subtraction, I get x equals negative 1. There's another answer. Now, whenever we get past simple equations like linear equations and stuff like that, it would be good if you knew for sure that it actually worked. I mean, occasionally go back and check. So if I take a negative 3 and I plug it in here, negative 3 squared is 9. 4 times negative 3, that's negative 12, and then plus 3. These add up to be 12. Subtract the 12, I get 0. So does the negative 3 work? It does. Let's check the negative 1. Negative 1, quantity squared, that's going to be a 1. 4 times negative 1, that's a negative 4. And add 3. Those do cancel each other out to make a 0. Okay? So those are the correct answers. All right? Any questions? All right. So there's a quick little technique for using the zero property of multiplication in order to solve these equations. So write the equivalent equation with a 0 on one side. So that basically means we always want to be comparing to 0 because there's no like multiplication property of negative 5 or something like that. Okay, or 8r, as is the case right here. So we always want to set it equal to 0. Factor the polynomial, set each factor equal to 0, okay, and then solve the resulting equations. So let's solve this one right here. It's set equal to 0, so step 1's done for us. We want to factor this, this polynomial. So what multiplies to be 20 and combines to be negative 12?
Negative 2, negative 12. Or 10.
Negative 2 and negative 10?
Yes.
Okay, all right. And let's see. I think I'm frozen up here for some reason. Let's see. Yep, I am, so I'm going to stop that. Start it up again and see where we are. Okay. So this would be negative 10 and negative 2. They do multiply to be a positive 20, combined to be negative 12. So what's the answer or the solution that comes from this factor right here? Okay, this is going to be x equals 10. Now, it's going to work this way every time, so please watch. If I were going to set this equal to 0 and then solve, I'm going to end up doing the opposite of whatever this number is. So that's why I get x equals 10. What's the answer that comes from this factor? This one's going to be x equals 2. So if it's just a plain old x plus or minus a number, you just grab the opposite of this. That's your answer. Let's come over here and take a look at this. Now I want to point out a couple things on this one. So everybody watch, please. So on this one, I've got 3t and I've got 2t minus 5. So if I were going to solve this, there are actually 3 factors here. There's 3, there's t, and there's 2t minus 5. Now, if you've got 3 things multiplied together and it equals 0, you know at least one of them is 0. Is the 3 ever going to equal 0? No. When would t equal 0? When t is 0. I mean, that's like its answer all by itself. And when would 2t minus 5 equal 0? Okay. So here's how you'd solve that. I'll do this one more time, and then I'd like to take the shortcut from here on. I'd add 5. I'd have 2t equals 5. And then I'd divide by 2, so I get, whoops, t equals 5/2. So the process is like this. If you want to take the little shortcut, and this works every single time on linear factors. If one of these is squared, you can't do that. Opposite of this number divided by that coefficient. Opposite of this divided by that. Opposite of negative 5 is 5, divide by 2. There's our 5/2. There are our answers. Okay, are there any questions there? Okay, so let's do this one. What's the solution that comes from this factor? Negative 3, opposite of that, divide by the coefficient. And this one right here, opposite of the negative 7, 7, divide by that one. There we go. Okay, it's that simple. Okay, what's wrong with number 29?
It's squared.
Okay, it's squared here.
It's not set to 0.
What else?
Not set to 0.
Okay, that's the first problem. It's not that this is squared, because we're fine with squares. We need to set this equal to 0. So I need to move the 8r to this side, and then I need to choose the best way to write this. So I'm going to write this, I've got a 0 over here. I'm going to write this in what order? Descending order. And I'm hoping that looks familiar. Now, you could do this. Numbers that multiply to be positive 16 combine to be negative 8. Negative 4 and negative 4. Okay, or it would be much better if you recognize, hey, that's a perfect square of r, that's a perfect square of 4. Multiply them together. This is r and 4 with a negative. So what's the 0, the solution, what's the answer that comes from this factor? R equals 4. Okay? Now, does it matter that it happens twice? No, we call that a double solution. Okay? What's wrong with 40?
Not set to 0.
Not set equal to 0. Thank you very much. That's the technique we're using here. So we've got r squared minus 4 is equal to 0. That should definitely look familiar. Two terms, and it's a difference. It's either got to be a difference of squares or difference of cubes. Which is it, Tyler? Difference of squares. So that's going to be r minus 2 and r plus 2, set equal to 0. Solution from here is a 2. Solution from here is a negative 2. Does anybody know another way to solve that one? John? Take the square root of both sides. If you put a square root in the problem, you've got to put a plus or minus. Square root of r squared would be r. Square root of 4 would be 2, but you've got to put the plus or minus there. We'll actually solve them using that technique later on in this course. Okay, what's really wrong with this one?
Not set to 0.
Okay, it's not set equal to 0, and it's already factored. Okay, but can you just write 3 and negative 2 and say you're done with it? No, because there's no 14 property of multiplication. So on this one, you actually have more work to do even though it was already factored. You have to distribute through y squared. This would be minus y minus 6 equals 14. Everybody see why it's minus y? Minus 3y plus 2y. Those would combine to be a minus y. See why it's good to be able to multiply those together quickly? Now set it equal to 0, so we're going to subtract 14 from both sides. So this is going to be y squared minus y minus 20 equals 0. And that better be an easy trinomial. We've actually done that one in class. We're looking for two numbers that multiply to be negative 20 and combine to be negative 1, negative 5, and positive 4. So the solution that comes from this factor, 5, and here, negative 4. Okay, any questions? Okay, flip the page over. You've got a few problems that look like this. It says f of x is x squared plus 12x equals 40. Find a such that f of a equals 8. F of a equals 8. Okay, now, I'm going to ignore these instructions right here. If I said f of x is this stuff right here, what is f of a? Yeah, what is it? Okay, that means whatever you put here, you plug into our equation. So if I put an a here, this is going to be an a squared, a 12a, and a plus 40, right? So this is going to be a squared plus 12a plus 40. That's what f of a is, right? What does this say f of a is? 8. So wherever there's an f of a, what am I going to put? An 8. So this is 8 equals a squared plus 12a plus 40, and then you solve from there. I'm going to set this equal to 0 by subtracting. So that's going to be a 32. Is that right? And then does that factor? Can you find numbers that multiply to be 32 that combine to be 12? You can. Okay, I'm not going to finish that one. I don't need to finish that, do I? Okay, take a look at the next one. I'm hoping this is easy. Tyler, say that again. Set them equal to each other. F of x is this, g of x is this, and it says find x so that f of x equals g of x. So we take 2x cubed minus 5x, set it equal to 10x, minus 7x squared. Okay, now, you have to set it equal to 0. My question for you is, do we want to move the right stuff onto the left or the left stuff onto the right?
Right to left.
Right to left. Let's move this stuff over here Because if we move it over on this side, it's going to start off with a 2x cubed. The leading term is going to be positive. It doesn't matter, okay? But I think that's going to be easier because we'd probably have to work with fewer negatives, okay? Or at least the same number of negatives, okay? So let's take a look here. If I move that over, I get 2x cubed plus 7x squared. If I move the 10 over here by subtracting, minus 15x equals 0. Okay, is that okay? Did I do that right? Okay, I'm not going to finish this one, but we will get started on factoring it. Take out an x. Thank you very much. Maybe we will finish this one. Got to factor this. So if you're good at guess and check, go ahead. I'm going to take the 2 and the negative 15 and multiply them together. That's a negative 30. Numbers that multiply to be negative 30 that combine to be positive 7. Multiply to be negative 30, combine to be positive 7. Okay. 3 and 10, those will make a 7, and I need the 7 to be positive, so I need a negative 3 and a positive 10. Again, double check at this point. Make sure you got it right. They multiply to be negative 30. They combine to be positive 7. So 2x squared minus 3x plus 10x minus 15. And look how promising this is, because I can take out an x. I'm left with a 2x minus 3. And why does this look good looking at this second group? What can I take out? Take out a 5. What kind of 5? Remember, say the sign and write that out front. You're left with a 2x minus 3. So I've got a 2x minus 3. I've got an x plus 5. And that's equal to 0. Am I done? No, because you better not forget that last rule in factoring. We mentioned that all the time. Now it's a huge deal because you'd be leaving out one of the answers. Okay, I'm going to switch colors here. What answer comes from here? Everybody watch. If you just have a plain old x, what makes x equal to 0? 0. Answer from here. Opposite divided by that coefficient. Opposite divided by that coefficient. What's that coefficient? A 1, so it's just negative 5. There are the 3 answers. Okay, are there any questions? Sure? Oops. Okay. So let's see, I've got a couple of story problems here. So let's run through these. A photo is 3 centimeters longer than it is wide. Find the length and the width if the area is 108 square centimeters. So if this is a problem on the assignment, what's the first thing you ought to do? What's that? Try and set up an equation. Even before you do that, draw a picture. It's about a rectangle. Let's draw a rectangle. It says the photo is 3 longer than it is wide. 3 centimeters longer than it is wide. Okay, well, so Tyler suggests we do x and x plus 3. Okay, I'm okay with that, but I'd rather you do this. Let's call that the width. We don't know what the width is, but we do know that the length is bigger than the width. So whatever the width is, we're going to add 3 to it. So width plus 3. Now, what do we know about this rectangle? The area is 108. And how do you find the area? Length times width. So 108 should be the length, w plus 3 times w. So we distribute through, w squared plus 3w. Move the 108 on the other side, so I have 0 equals w squared plus 3w minus 108. And then I need to factor that. So if you need a calculator for this, I mean, this is a great test question. We need numbers that multiply to be 108 that combine to be 3. So 108. 2 goes in there 54 times. That's certainly not going to make a 3. Yeah.
9 and 12.
Okay, so somebody's been working ahead 9 and 12.
Negative.
Or he's just really smart, right?
Positive 12.
Okay, need to multiply to be a negative and combine to be a positive. So, negative and positive, right? So this is going to factor to W minus 9 and W plus 12. That's equal to 0. Answer from here, positive 9. Answer from here, negative 12. So I'm going to write W equals 9 and W equals negative 12. Which one's the right answer?
9.
Okay. Width is a length. It's a distance. So it's got to be positive. So we'll cross this one off. If you know the width is 9, then you know the length has got to be 3 more than that, so it's got to be 12. So no coincidence that those two numbers came up here. We select 9 for the answer, add 3 to that. There we go. Okay, any questions? Okay, watch. Don't write this down. Just watch. What if I said I don't know the length, but the width is... How would I represent that?
3 less than
3 less than that. So do I do 3 minus L or L minus 3? L minus 3. You could solve that same way. You'd solve that and you'd get the length rather than the width. Okay? All right. Let's talk about number 81. I'm sure you've seen these before, but for some reason these give people trouble. Okay? 3 consecutive even integers are such that the square of the third is 76 more than the square of the second. Boy, that sounds complicated. Okay, so just watch. You don't need to write this down. We're talking about even numbers, right? So let's say I write down 16, 18, 20. Those are consecutive, right? Okay, how do I go from the first even one to the next even one? How far is it in between them? 2. How far is it in between these two? 2 again. How far is it from the first one to the third one? 4. So if I say this is the first one, this is the second one, and this is the third one, if I don't know what the first one is, let's call it X. How do I go from the first one to the second one? Add 2. How do I go from the first one to the third one?
X plus 4.
Okay. Add 2 to this one again, or add 4 to the first one. So here's the first one, here's the second one, here's the third one. That's enough to write the equation, because I need to take the square of the third one, that's this one, square it, is 76 more than, is, equals 76 more than the square of the second. What's the second one? X plus 2. Square that. Now, which of these two is bigger? The first one or the second one? Or sorry, let's do left side and right side so we don't confuse them. Left side or right side? Left side is bigger, right? So I need to take this side and add 76 to it so it equals that side. And then multiply them out, collect the like terms, and you've got your answer. Now, the cool part about that one is the factoring is, gosh, I don't even think you have to do any factoring, because the x squareds are going to cancel. Okay, everybody good there? Okay. Multiply these out, collect like terms, solve it. Okay. Questions? Okay, I need you to watch here then. What if I changed this problem and I said now they're odd? Does that change how you set this up? Okay, intuition would say, well, wait a minute. If it's even, look out, these are even, that makes sense. But if they're odd, a lot of people think, well, this would be x plus 1, and this would be x plus 3. Okay, let me show you why that's wrong. 17, 19, 21. How far is it in between those two? 2. How far is it in between those two? 2. So how far is it from the first one to the third one? 4. So the interesting part about this is, if the first one is x, the next one is x plus 2, and the next one is x plus 4. Okay? If we're talking consecutive odd or consecutive even. All right? The pattern is the same, because they're always 2 apart from each other, right? Every odd is 2 apart, every even is 2 apart. Okay? What if they just said consecutive integers?
Speed X
9, 10, 11, 12. X, how do you get to the next integer?
plus 1.
Add 1. Add one more. Add one more. So it would be x, x plus 1, x plus 2, x plus 3, whatever. Okay, got that? Okay. Okay, would you read that problem? Okay, hopefully you've got some scratch paper somewhere, some space that you could write this down. An antenna is stretched from the ground to the top of an antenna tower as shown. So they've done us the favor of drawing a diagram. The wire is 20 meters long. The height of the tower is 4 meters greater than the distance from the tower's base to the bottom of the wire. Find the distance d and the height of the tower.
Why?
This is easy geometry though, right?
Still geometry. No for geometry, this one.
It's a right triangle, right? I know this is 20. Okay. The height of the tower is 4 greater than the distance. And it's got this labeled as D. So I'm going to put a D right there. The height of the tower is 4 greater than the distance that the wire is from the base of the tower. What do I write here? D plus 4. Okay, now, the geometry is almost over if you know how is this leg and this leg related to, what do we call this again? Hypotenuse. How are the two legs related to the hypotenuse? John?
The square root of d and the square root of d plus 4 equals square root of 20 squared.
Okay, you're on the right track. Let's make sure we say it right. You can square the two legs, add that together, and it should equal the square of the hypotenuse. So you might remember a squared plus b squared equals c squared. These are the legs, and this is the hypotenuse. So that means d squared plus the other leg squared, which would be d plus 4 quantity squared. Make sure you put that in parentheses, equals 20 squared. Now, please do not do this. That's not what it is it? Okay? Because you've ignored the fact that when we multiply these together, d plus 4 times d plus 4, that's d squared. That's 16, but this is a 4d and that's a 4d, so the middle term should be 8d. It's that pattern for a perfect trinomial square. Solve that, that'll tell you what d is. Okay, are there any questions? By the way, what if you solve it and you get 2 answers and one of them's negative? You throw it out. Okay, it doesn't make sense in that particular situation. Okay, read that problem there. Sounds like a fun fireworks display launching from an 8-story building. Sounds pretty cool. How long will it take the cardboard shell from the fireworks to reach the ground? So this is an equation that represents how high it is, the height of the shell off the ground. And we want to know when it hits the ground. Well, the ground is right here, right? If this is the h-axis and this is 80 on the h-axis, guess that looks like it's maybe about 150, maybe it goes 150 feet high. What's the ground? 0. It's got a height of 0. So how do we solve this problem? Yeah, just say 0 equals negative 16t squared plus 64t plus 80. And what's the first rule in factoring? Take out the greatest common factor. This looks awful, looks absolutely awful, but if you take out a negative 16, you're left with a t squared. a minus 4t, and a plus 5. Nope, minus 5. And that factors pretty easily, okay? Let's finish this because this has kind of an interesting answer. Multiply to be negative 5 combined to be negative 4. Negative 5 and positive 1. Okay, so this would be t equals 5. This would be t equals negative 1. And does negative 16 ever equal 0? It doesn't. So that factor doesn't, it's not going to be the factor that makes it equal to 0. Okay, so we only have two answers on here. So our choices are t equals 5 seconds and t equals negative 1 second. Now which one's the answer? Clearly 5. But can somebody tell me what this means? I mean, it does kind of have a meaning here. Zach?
Is it like, I want to say it's like how many seconds pass where it would actually hit like the 80-foot mark?
Okay, you're on the right track. Okay, here's what happens with this model. We start a stopwatch right when it's launched here. So anything positive is going forward in time. Anything negative is like going backward in time.
Oh, shit.
So if we went back in time 1 second, if we could go backwards from where it was launched, it would have been on the ground before. So this is a mathematical model for the motion. It breaks down because did it really travel back in time through the building and hit the ground? No. Okay? All right. But that's what the meaning for that mathematical model would be. Yeah.
Do we do anything with the t-squared? Or just
What do you mean?
ignore it?
What do you mean?
Because we take out
Right.
negative 16.
Just a negative 16. Okay. Good? Okay. All right, you've got about 15 minutes or so. Again, please get started on this assignment. Make sure you come on Monday, have downloaded the review, have looked at the review so you know what questions to ask, because this is your next big test. If you weren't happy with the way things went on that first test, this is the next best opportunity you're going to have to improve your grade. Okay? All right.
So are we going to have a review assignment? Like review?
Yeah, just like regular. The review assignment is an assignment out of the book. It's due. You have to turn it in. Okay? Counts for points, all that good stuff.
Alright. And when is that due? The day of the test?
Day of the